So now we're looking at two other observational study types. The second one is called retrospective, or sometimes called case-controlled study. Retrospective means looking backwards in time. You look backwards in time, you find some data, and match subjects up so that the primary difference is the varying levels of the explanatory variable, which I can't spell. Very good. Then the current response variable values are observed. So things like that, you're wondering whether or not some activity that's been taking place for a long time has given the result that you want at the end of the day. Or maybe the result you don't want at the end of the day. Here's some questions that I'm interested in studying. Does running cause knee joint failure? I've run a bunch of marathons. People always tell me, well, when you get old, all the running you did and training you did, I can't see myself, there we go. All the running you did and training you did probably wore your knee out, and you're going to need knee replacements. It's kind of too late now, but it's something you might want to study. That would be a retrospective study. What would you do to do that? Well, you would perhaps locate a bunch of people that had knee replacements and find out if they were runners as a kid or a middle-aged person, and compare that to people that don't have knee joint replacements. Were they runners as young people? So what's the prevalence of running among knee joint replacers versus not knee joint replacers? And comparing those two groups, you might be able to tell if the runners tend to have more knee replacements, or vice versa, if knee replacement people tended to be runners and non-knee replacement people tended not to be runners. That might be possible. The second question that's interesting to study is getting a college degree really worth it? So what would you do there? It's a little bit hard to do because the notion of college degree changes over time, and what it gets you changing over time. So you can't really answer that question without following people forward right now. Getting the current college degree, is it really worth it? You'd have to take the people who are getting the degree right now and look at them in 20, 30 years to see what happened. But I guess you could find out some things. Maybe you could contact maybe people in their 50s. What do you mean by worth it? Well, money, I suppose. How much money do you have now? You could find out their net worth. So just randomly select, hard to pick them. So a bunch of 50-year-olds, say pick that age, and find out their net worth. This doesn't say difference. This bothers me sometimes. Difference. Where is it? There we go. You're finding those 50-year-olds, you're finding their net worth, and you're finding how many years of college they had, and see if there's a connection between how many years they went to school and how much money they have now. And that would be, did the college degree really pay off? And then I suppose you'd have to subtract off how much the college degree cost, because otherwise they might have that extra money. You could do some other fancy stuff with it, but you might be able to do that. So that what that says is we're looking at current information, what's your current net worth, and we're comparing it to something that happened before, how much school did you have, and try to figure out whether there's a connection between schooling and net worth. That might work. The third kind of study is here, prospective or cohort study. Prospective means you go forward in time. Researcher follows subjects forward in time and tracks values of the explanatory variable or variables. After some time, the response variable values are observed. So that means you're going to keep track of some kind of behavior. And at the end of the day, you're going to, so that if we did that, we could follow people forward in time that are runners and see later on if they happen to have knee joint failure. So I have to wait a long time, but I guess you could do it. The benefit of that possibly would be that you'd have more opportunity to examine other possible explanatory variables, because you'd get to see what other things people were doing at the same time they were running that might cause them knee joint failure. Or you might see the other things people are doing when they're going to college. Otherwise, you're just asking them a question, how many years of college, how much money do you have? That's not the same as watching them go through the process and see what happened. So prospective studies should be better at determining cause and effect than retrospective studies, I would think. Following them forward to time after, okay, so it says, here's one thing I'd like to do, but I can't do it. Do calculators inhibit understanding of math? Maybe they do, maybe they don't. Some people say they help, some people say they hurt. Compare performance on exams for students in college math classes that allow or forbid calculators. So there's some schools where you, in your first couple of years of math classes, you just can't use a calculator at all because they think it causes damage. And then there's some schools where you're required to have a calculator to do your class because they think it helps. So we could take those two groups and see those students going through math classes and then very carefully ask them questions. It's really hard to know what to ask, because you can't ask the non-calculator people calculator questions, and it doesn't make sense to ask the calculator people questions that you might have had to do without a calculator, so somehow you have to ask something else. What does it mean to understand math? Some conceptual questions, so it's difficult. There's a political problem here. What does it mean to understand math? The setting up the experiment seems pretty simple, but deciding how to assess the students is very difficult. Finally, a prospective or cohort study. Here we're going to wonder whether new computer controlled braking systems prevent accidents. You know that when you're trying to back up and somebody's coming on the side road, it beeps, it steps on the brakes, or you're in a cruise control mode and there's radar on the front of your car that keeps you from running into the car in front of you if you're not paying attention. Do you think that works? Is that actually helping? Or is that maybe making people more willing not to pay attention because they're just assuming the car is going to take care of the problem? And that might be even worse than, you might not even look. You could just back up and go, well, the computer's going to see if there's a car coming. Why should I worry? And hopefully there's not a person crawling along the ground behind the car or something like that that would cause a problem. Or maybe there's a tree right behind you that the computer's just looking for moving stuff. Who knows? Interesting. How would you perform that study? Well, you'd have to get a hold of some people that have these new cars and then follow them forward in time for a couple of years and see what kinds of accidents they have. And then we could maybe take another group of people at the same time that have maybe just purchased a used car or something that doesn't have these computer-controlled braking systems, and follow them forward in time for a few years. And then look at the accident records of the two groups and see if the computer-controlled braking group has fewer accidents than the non-computer-controlled braking group, and see if that actually works. That could do it. And that'd be following subjects forward in time and track values of the explanatory variables. So you need to be tracking whether they're in a computer-controlled braking car or not, and then you just see how many accidents they had. Well, that kind of ends this section. A lot of definitions and conceptual problems and no calculating. That happens for a while, and then we swap back and forth between definitions and procedures and calculations involved in those procedures. So the procedures and the calculations involved looks like a math class, but all the definitions and conceptual questions looks like something else, like a social science class. So that makes statistics attractive or not attractive to people that are good at certain things. If you're good at all three of those things, then it's a fun class. If you really like math and formulas, well, you'll be happy half the time. And you really like reading and understanding concepts and definitions, you'll be happy half the time. So you're going to have to use both sides of your brain. I think that's what they would say. Whether both sides of your brain actually exists anymore, I'm not sure. If the researchers still think we have two sides and two ways of thinking. That changes as time goes on. And so does this class. So we will see you when we go on to the third section, which is coming up next, but you might wait a while to do that and look at some of the homework for these first two sections.